Hey everyone, so now that you know how to calculate the slope and find the linear equation of a line, what's the next challenge? Well, the next thing is to figure out the linear equation of parallel lines and perpendicular lines. If you have no idea how to calculate the slope of a line, then click on this link up here to watch the first video in this 3-part series. On the other hand, if you know how to calculate the slope, but you don't know how to use the slope to figure out the linear equation of a line, click on this link up here to watch the second part of this series. Otherwise, keep watching this video to do something a bit more challenging, like finding the equations of parallel lines and perpendicular lines. My name is Peter. Grab your calculator and let's get started. To be able to find the linear equations of parallel or perpendicular lines, we need two objectives. The first objective is for us to determine whether lines are parallel or perpendicular. And then the second objective, once we've figured out that the lines are parallel or perpendicular, now we can actually write the linear equations of those parallel and perpendicular lines. If the first objective is not met, then the second objective cannot be achieved. The first objective is to determine whether lines are parallel or perpendicular. When it comes to parallel lines, non-vertical lines are parallel if they have the same slope and different y-intercept. So here's an example of how that would look like. These two lines are clearly parallel, and we can confirm that by looking at the slopes of each line. Then the two lines are parallel. How do we determine if lines are perpendicular? Well, two non-vertical lines are perpendicular if the product of their slopes is -1. There's a bit of calculation that's involved here, and we're going to do that later on. But graphically, if the two lines form a 90-degree angle, then the two lines are perpendicular and we can determine their linear equations. Let's determine if the following lines are parallel. So number one, we have the first line has a slope of -3/2, and the second line has a slope of +3/2. Those are the only two numbers that we need to compare to determine if lines are parallel. Since these two slopes are different, that means no, those two lines are not parallel. In the second example, we have a slope that is -2/3, and the other line has a slope of -2/3. Since those two slopes are the same, then yes, those two lines are parallel. Number three, we have a slope of +2/5, and we have the second line with a slope of -5/2. Those two slopes are different. That means no, the two lines are not parallel. In question number 4, the first line, the slope is a +3/5. The second line in the fourth example, we cannot quite yet determine the slope because that line is not written in the slope-intercept form. In this video series, all the lines that we're going to be looking at need to be in the slope-intercept form, which is y equals to mx plus b. So that means we need to rewrite that equation to look like that slope-intercept form. So the first thing that we're going to do is divide both sides by 5. Divide 5y, divide by 5, you just remain with the y. And then when you divide 3, divide by 5, you get 3/5x. And then you also need to divide -10, divide by 5. After you divide by 5, in the first fraction, when you divide by 5, it cannot simplify, so it just remains 3/5x, but -10 divided by 5 gives you -2. Since it's in the slope-intercept form, now we can compare that slope and the first slope, and we see that they are identical, and that means yes, those two lines are parallel. Let's determine if the following lines are perpendicular. So the rule for figuring out if lines are perpendicular is when you multiply the slopes of the two lines, the answer should be -1. So the first thing we're going to do in these two lines, we're going to identify the first slope and the second slope. The first slope is +2/5 and the second slope is -5/2. So if we multiply 2/5 times -5/2, our final answer should be -1. So let's go through the process. 2 times -5 is -10. 5 times 2 is +10. This fraction here can be simplified by dividing both numbers, and our final answer is -1. That means these two lines cross each other and they form a 90-degree angle, so they are perpendicular. In question number 2, we need to determine the first slope and the second slope. The first slope is easy. It's going to be positive 7. But in the second equation, we can't quite yet figure out the slope because that equation is not in the slope-intercept form. So we need to rewrite it. In this video, we're going to rewrite all the equations in the slope-intercept form, which is y equals to mx plus b. The first thing we're going to do is we're going to write the 7y. So the first thing that we're going to do is we need to isolate the y variable. So that x that's here on the left side, we need to move it over to the right side. Since it's positive, when it goes to the other side, it's going to become a negative x, and then we add the positive 8. Now, if you want to isolate the y variable, you need to get rid of the 7. So divide both sides by 7, and you will get y equals to negative 1 over 7x plus 8 over 7. Once we have the equation in this form, we can easily determine the second slope is negative 1 over 7. So if we multiply positive 7 from the first slope times negative 1 over 7 from the second slope, we need to get a final answer that is negative 1. So when you multiply 7 times negative 1, you get negative 7. In the denominator, it remains 7. This fraction can be simplified by dividing both numbers, and your final answer is negative 1. So negative 1 indicates that these two lines are perpendicular. They form 90 degrees. In the second objective, we're going to use all the skills that we learned from the first objective, and now we'll be able to write linear equations of parallel and perpendicular lines. The strategy is pretty simple. Use the slope to find the second linear equation for either a parallel line or a perpendicular line. When it comes to figuring out a parallel line, you need two things. The first thing is you need a given line. The second thing is you will be given a point somewhere on the graph. You need to use the slope of the first line and the point that's given to come up with a line that is parallel to the given line. When you want to figure out what the perpendicular line is going to be, you need two things as well. You need a given line, and you need to know what that slope is, and then you need a point of the second line, and then all you need to do is to figure out what is the linear equation of the line that is perpendicular to the first given line. So the first example we're going to look at is how to write the linear equation of a line that is parallel to the given equation and it passes through the given point. The given equation is y equals to 3x plus 6, and so the first thing is we need to figure out what is the slope. So the slope is going to be m1, which is positive 3. Since we're dealing with parallel lines, that means that the slope of the given line, m1, is going to be equal to the slope of the line that we're looking for. So the next thing that we need to do is to write the final answer in the slope-intercept form, which is y equals to m2x plus b. We are going to substitute the y value, the slope value, and the x so that we can figure out what the y-intercept is. So the y value is simply going to be 7 from the coordinates that we're given, and this is equal to the new slope, which is 3 times 4, which is the x coordinate, plus b. So when you multiply 3 times 4, you get 12 plus b, and then all we need to do to get b alone is to subtract 12 from both sides, and you get b is equal to negative 5. That means the linear equation that is passing through 4, 7 is going to be y equals to positive 3x minus 5. In the second math problem, we have an equation y plus 2x equals to 4. This equation here is not quite yet in the slope-intercept form. We have to rewrite it so that we can get the slope from the equation. So this positive 2x, we need to move it over to the right side. And we're doing this so that the equation is in this form, y equals to mx plus b. So when you move that positive 2x over to the right side, you're going to have an equation that is y equals to negative 2x plus 4. Once it's in this form, we can easily see that the slope is negative 2. Since we're dealing with parallel lines, this slope from the given line is going to be equal to the slope of the line that we're looking for, and we're going to call it m2. We're going to substitute the y value here with a positive 2 from the y coordinate, and this is going to be equal to our slope, which is negative 2, and we're going to multiply times the x coordinate, which is negative 1, plus b. We're looking for where the line crosses the y-axis, the y-intercept. When you multiply negative 2 times negative 1, you get positive 2 plus b. If you want to solve for b, all you need to do is to move this positive 2 over to the other side by subtracting 2. That gives you a b value of 0. Since we have our b value and our slope, our final answer is going to be y equals to negative 2x. In the second exercise here, we need to write the linear equation of the line that is perpendicular to the given equation and passes through the given point. In these exercises, since we're looking for perpendicular lines, we need to remember the relationship between the two slopes of perpendicular lines. If you multiply the two slopes, your answer should be negative 1. In the first math problem, we have y equals to negative 5x plus 1. This is the given equation. So when you identify the slope, you'll see that it's negative 5. If we multiply negative 5 times the second slope, we should get negative 1. So we're going to write negative 5 times m2 equals to negative 1. If you want to solve for m2, all you got to do is divide both sides by negative 5, and the second slope is going to be positive 1 over 5. And the next thing is, now we need to take that slope and use the slope-intercept form, which is y equals to mx plus b, to figure out what is the y-intercept. So we're going to substitute the y value with the given y coordinate, which is negative 1. We're going to substitute the second slope with the slope that we just calculated, which is 1 over 5. And we're going to substitute the x with the positive 2 plus b. So when you multiply the fraction times 2, you're going to get negative 1 equals to 2 over 5 plus b. When you want to solve for b, this is a simple one-step equation. You need to move the fraction over to the left side. B is going to be equal to negative 7 over 5. Since we have our b and we have our slope, our final answer is going to be y equals to 1 over 5x minus 7 over 5 as the final answer. In the second math problem, we have 7y plus 4x equals to 3. This equation here is not in the slope-intercept form, so we need to rewrite it by putting it into the form that is y equals to mx plus b. This 4x, we're going to move it over to the right side, and we have 7y alone, and on the other side you're going to have negative 4x plus 3. To isolate the y variable, we need to divide both sides by 7, and so y is going to be equal to negative 4 over 7x plus 3 over 7. So we can see here that our slope is going to be negative 4 over 7. This is the slope that we're going to use to figure out the slope of the perpendicular line. So if I multiply negative 4 over 7 times the second slope, I should get a negative 1. So we're going to write negative 4 over 7 m2 is equal to negative 1. If you want to figure out what m2 is, all you need to do is to multiply the left side times its inverse, and you're going to get m2 equals to positive 7 over positive 4. So now that we have our slope, we're going to use the slope and the slope-intercept form to figure out the value of b. So we're going to substitute the y value with negative 7. So we're going to write negative 7 is equal to, we're going to substitute the slope with 7 over 4, and we're going to substitute the x here with negative 4, and then the only unknown is the variable b. Now, since here we're multiplying this fraction with a denominator of 4 and the negative 4, those two numbers have a common factor, which is 4. So we can divide those two numbers, and when you divide them, you get negative 1. So that means our equation is going to become negative 7 is equal to negative 7 plus b. So to solve this one-step equation, we just need to move this -7 over to the left side, and you're gonna get 0 equals to b. We have our b value, we have our slope, so the final answer is gonna be y equals to 7 over 4x. Alright, here's a quick pro tip. If you want to figure out the equation of two parallel lines, you gotta remember, two parallel lines, it doesn't matter what direction they're gonna have the same slope. On the other hand, if you want to figure out the equation of two parallel lines, you need to remember the product of their slopes will be equal to -1, and that's the pro tip. After working on a couple of examples, here are some independent exercises for you to try on your own. In the first exercise, you need to write the linear equation that is parallel to the given equation and passes through the given point. In the second exercise, you need to write the linear equation of the line that is perpendicular to the given equation and passes through the given point. The answers to the two exercises can be found in the description box below. Good luck!